Hey, Troy here with Lithogen. I am starting a short video series where we're going to go through the various devices that we have in our inventory. And we're actually going to scan our own property here at Lithogen, the yard of the warehouse and these sorts of things, as well as the public lane that's in front of the property. We're going to go through the equipment step by step, from the equipment arriving at the customer right through to data processing. And we're going to link a copy of the data set afterwards. So our warehouse is going to be the most well-characterized geophysical site probably on the planet. Behind the camera here is my electronics technician, Bertrand. Hi, Bertrand.
Yeah, hi.
And you're going to see him carrying some equipment around, and we're going to take turns here with the different roles. We're going to start with the EM38 today. And this is effectively the EM38 as it arrives to the customer. The orange box is the EM38. Usually there will be some extra foam and some padding in here with the data logger and the GPS. Today we're going to use the older Archer 2 data logger because a lot of the EM38 customers prefer it because it is more ergonomic to hold in your hand than the larger Mesa tablets. So this is much easier to carry like this than the large displays. Just going through the contents of the box. This is the EM38-mk2, the orange one. We also have the EM38-4, which is yellow and has additional receiver coils. This one has 2 receiver coils. It's a bit of a console here. If you're using the 9-volt battery, there's just thumb screws to remove it. And this is the 9-volt battery here. It just connects and disconnects just with a standard 9-volt connector. There is an external battery that plugs in here. We have it charging right now, so I'm not going to show it to you. But if you prefer a rechargeable lead-acid battery, this is where it would plug in. On the EM38-4, the 9-volt battery option doesn't exist because you need more power to power the additional coils. First thing we're going to do is set it to battery mode by switching the mode selector to BAT. And you can immediately see that the screen lights up. On the video here, the screen's going to be upside down. So this is reading 806 or 816, something like that. This is the voltage on the battery. Because it's a 9-volt battery, if it's reading 8, the battery is actually kind of lowish, but it'll still survey. If you put a fresh 9-volt in there, it'll probably be about 950 it'll be reading here. If it drops too low, the system will just shut off and you'll have to change the battery. Normally when you're surveying, you put it in QP mode, but with the modern instrument, it doesn't really matter that much. What you set the dial to here dictates what's shown on the screen. The newer EM38-4 doesn't have this screen anymore because everything is done through a digital data logger. If you were manually writing things down with a notepad, the values on the screen would be important. Any of the modes here, except battery, enable the Bluetooth module inside, and all of the information automatically goes out to the data logger, assuming you've connected it via Bluetooth. Or if you're using a data logger with a serial cable, you would use this connector here and the serial cable that we ship with it. Very few of our customers will actually use the serial cable. The only time it's really used is if you're using your own data logger, or for example, you're mounting it on some farm equipment and that farm equipment has a computer inside you want to connect it to, and it doesn't have Bluetooth. Normally we recommend the Bluetooth connection. The cable is one more thing that can be broken in the field. This is the Archer 2 data logger. I believe they're up to an Archer 4 now if you buy the new ones, but the new Archers are Android-based devices, and these are the old Windows embedded devices which run the software. So we can't get the newer devices and get the data logging software unless you're using third-party software. To turn it on, it's one push of the power button, and it should wake it up from sleep. If it was shut down totally, you're going to wait probably about 20 seconds for it to boot up. Additionally, there is a power button on the side of the GeoGPS. This is the GNS2, which has been replaced by the GNS3 recently, but they're basically the same. There's a serial connector on the back here. On some systems, you need to use the serial cable to get GPS data out of here, but these two are actually going to be connected via Bluetooth. And right now, I'm going to show you how to do that. Hopefully this film's okay, without any significant glare. If you turn the device on, sometimes Bluetooth is turned off. You can toggle the Bluetooth on and off by pushing this button here. Additionally, if you want to configure the Bluetooth, if you long press on the Bluetooth icon, you can hit COM ports, GPS, and RFID. If you have existing devices in here, you usually want to select them and then use the menu option to delete them. There's a limited number of COM ports on the device, and if you try to pair with additional devices while those COM ports are in use, it will not work. Delete the existing connections first. Then hit Discover Devices, and it will go through its Bluetooth pairing dance. In a moment, we're going to see some devices showing up here. You can actually see our EM38. There's a couple of other things showing up. We're going to pair first to the EM38. We'll note that the serial number matches the serial number on the device. So there's a tag here. It ends in number 603, hard to see on the film. If you have multiple instruments, be careful about the serial number. If you only have one, that makes it easy. And then just hit the connect button. After it's connected, a COM port will show up here. Sometimes it doesn't correctly guess the password. The password on all Geonics Bluetooth modules is a very secure 1234. All right, it connected to the device and it chose COM9. We're going to hit Discover Devices again. And we're going to do the same with the Bluetooth. The Bluetooth device has a serial number on the bottom of it. In this case, we can see the serial number ends in 944. In our list of Bluetooth devices, we can see Geode 944. So we're going to hit that and then connect. And it goes through trying to guess the password for the Bluetooth connection. Sometimes it gets it right away. Sometimes it's going to prompt you for the password. The password for the Geode is an equally secure 0000. Make a note of which COM ports these are, COM9 and COM7. COM9 for the EM38, COM7 for the Geode. We're now going to launch the data logging software, which is usually represented on our devices by an icon down here. Sometimes you have to use the File Explorer to go find it on the device, depending on which data logger you're using. And then we're going to use logger options, and we're going to make sure that our EM38 port is set to COM9. I did this previously, so it's already set to COM9. There's a couple other options here. We're going to leave them as is and press OK. Then we're going to do the same with the GPS port. Right now the GPS port is set to COM9, but the EM38 is COM9, so we need to change that to COM7. And I'm going to hit Monitor GPS Output. And here you can see the expected GGA and GSA strings. If you're seeing a lot of stuff scrolling by here so fast that you can barely even see it, something is wrong with your GPS configuration, and you need to go to your Geode Connect app and turn off all the strings except GGA and GSA. Next, we're going to hit Monitor Log and see if we have a good connection with both the Bluetooth and the instrument. And you can see here at the bottom we have some data coming in. We're inside a shop, we're on a metal table. This is not really that great. You can also see that the GPS is saying no fix. If we look at the lights on the GPS, this light will turn orange, flashing orange, once it starts getting a GPS lock. This is Bluetooth light, this is low battery light. That's power. If we go outside right now, we should see it switch to fix fairly immediately. So that's what we're going to do. Just gonna close the lid on here and grab this with one hand. And you can see as I move this thing around in the shop, there's all kinds of rebar in the floor and like metal and stuff like that. The values are swinging around randomly. It's not very good. What we're going to do is we're going to go outside to a quieter spot in the yard and we're going to see what it looks like there. I'm also going to grab the calibration pole with me. So we're outside now and we're going to go through the pre-job calibration and a couple of checks here. You can see I have the data logger here, the EM38 is on, and we have the calibration monopod here. Get Bertrand to come a little bit closer and we'll see if the screen films nicely. It might be too bright.
This is no solution to increase light.
Okay, we brought out one of our poster signs to create a shadow. Going back to the EM38 app and hitting monitor log. It says same port assigned. Okay. What happened is the GPS port got set to COM9. Now that we're outside, you can see at the bottom of the screen we have 25 satellites. We're going to go through the calibration process, and that requires me to hit the calibrate button here. And it says place EM38 on monopod in vertical dipole mode. So this is Bertrand with the monopod here. And it just kind of pops in there. You can see there's a ball that pops in. So once it's on the vertical monopod, I'm going to hit yes on the screen because it's asking, it's going to do a little bit of clicking. Now it says rotate to horizontal within 60 seconds. That means do that. There's a tilt sensor inside and it does it automatically. Now you can see our values are pretty close to 0 on the in phase and pretty close to 0 on the conductivity. This means we're calibrated and ready to survey. The next stop, you can take that off the monopod now, is to create a file. It will automatically name it based on the current date and time, but you can name it something else like your site name or something like that. Hit save. And then at the bottom, just hit go. And then we're ready to survey. So I'm gonna switch to putting the phone back on the tripod here and we're gonna begin surveying. Okay, Bertrand is just getting ready to go here, getting comfortable with his sleeves and things. When you're doing this sort of survey, you can't have steel-toed boots on because it will interfere with the instrument. As you can see, it's really close to the sensor. On the screen here, the only thing he has to do to start surveying is hit the go button. So I'll get him to do that now.
Press it for me.
Okay. And it starts beeping away. I'm going to set this up here. And he is now underway. You can see there's some obstacles in the yard. An old fishing boat that probably needs to go in the trash. There's lots of metal in that trailer, even if the boat's made out of fiberglass. When you're doing your site map, you'll want to note that down. A boat was parked here, because that anomaly is not going to be an anomaly in the ground. It's going to be a proximity anomaly between the sensor and the boat. the ramp that my car is sitting on there is not putting it on display for a car dealership. Just kind of getting it out of the lot so that it's not part of the survey. The ramp itself is going to be such a huge anomaly that it doesn't really matter that the car is there. Ideally, the lot would be entirely cleared prior to surveying, and the only objects that you cannot move, like the fences, the ramps, etc., remain fixed in place. Unfortunately, the boat has seen better days and isn't going anywhere. Just coming to see what the data looks like. You can see some peaks and troughs here as he's approaching and leaving the fence. The fence is such a huge anomaly that every time he gets there, you see a huge spike. This alley is probably full of rebar and conduits and other things. It's actually a terrible EM38 target because it's going to be so noisy, so full of crap, that the data is not going to be useful in any way. But we're going to survey it anyway, just to show what bad data looks like. You can see a manhole cover here. As he goes over that, we expect a huge spike. In this section, he's going perpendicular to the alley, whereas in the other alleyway here, he was going parallel with the alley. It'll be interesting to see if that makes a difference to the data. Sometimes there's utilities that are running along an alley, and it's much easier to find them if you survey in a direction that is perpendicular to your expected utilities. We might end up pausing to let this delivery truck go so that we can survey where he's currently parked. I did talk to the neighbors beforehand to make sure that they were okay with us crossing onto their property as we surveyed this alley. As with all geophysics, property rights are important and respecting them is important, and you should always ask for permission before even walking on a site. You can see overhead power lines here, which the EM38 is likely not sensitive to in any way. However, if we were doing an EM31 survey here, which has a larger volume of averaging, the EM31 would likely pick up the power lines overhead as you're going under them. Very likely, though, it's masked by the signal of the rebar in the alley. The lot on this side here is asphalt. We're not expecting any rebar there, but you can see there is a manhole cover there, so there's likely some buried utilities. This section here is the city-owned alley. We're expecting rebar under this alley. Finally, our neighbors on this side very likely have rebar under their pad because it is a concrete poured pad. But it might not be as bad as the alley. Bertrand is getting warm, so he took his sweater off for this section. He's walking, I'm filming, so that's a little bit unfair to him. What's interesting about this back lot here, and thanks to our neighbors for access, is that there used to be a railroad through here. This is why our lot has this weird circular wedge shape. Our building used to have rail service and a rail dock right here, so the railroad would have gone through there. What we're interested in finding here is if there's a soil difference picked up from the former rail bed versus the rest of the back lot. So Bertrand is scanning back and forth. Obviously the fences are going to be the biggest signal when you're close to the fence, but hopefully the soil difference is noticeable. Both buildings have stucco on the walls, which means there's a wire mesh under the stucco. So even if it looks like concrete, sometimes it's going to be a conductor. There's also the gates, some sheet metal. Let's see if they get close enough to the instrument. Back inside now. We just paused our recording outside, and you can see the last couple lines were really spiky, going back and forth between the two buildings. So that's expected because there's metal in the walls of the buildings. What we're going to show next is data dumping. So everything is still on because we just brought it inside, including the device. So what we're going to do is we're going to hit exit here. Exit logging, yes or no? Yes. And then I'm going to hit the power button on the GPS to turn it off to save some battery. And then also on the EM38, it's just going to go off. On the program here, if we hit exit, there's an icon that's usually found in Windows Mobile called File Explorer. And in the folder DAT38-mk2, you can see the file that we just collected. This has the same file name as the one that we chose by default earlier. If you had selected a different file name, it would be here. Note that the file size is not actually that large. It's only 1.2 megabytes. I'm going to long press on this file and choose copy. Using a USB stick, and the only secret here on the USB stick is it has to be formatted for FAT32. You insert the USB stick at the bottom, and USB has a magical property of being backwards 3 times. Oh, only twice this time. It takes a little bit of time for the device to recognize the USB stick normally. If you hit the drop-down menu and you see hard disk on here, this is the USB stick that we just inserted. There's some existing files on this USB stick because this is the USB stick that was sent from the manufacturer, which includes a copy of DAT38-mk2. But we're going to use it for dumping because it works just fine. So I'm just going to long press here and hit paste. You can see copy file over. Once the file is copied over, we can close the file manager as long as this light isn't flashing here. Pull the USB stick. And now we're ready to go do the computer portion of processing. If you want to save battery, push and hold, choose power off. using Google Meeting to record my screen, which is an interesting attempt to backdoor the system, so to speak. We're going to attempt to process this data. I've actually gone through it once prior to recording this video, just to make sure that the data was in fact okay, so that I don't get any hiccups while recording the video. First thing is, the data was recorded in a file with an N38 data format. This is the raw data format that the logging software on the device spit out. And you can see it's 1.2 megabytes and exactly the file that we copied off of the device. There's a couple of conversion steps that you need to go through in order to convert this data. I prepared some notes. The first is that you need to load the program called DAT31-mk2. Sorry, DAT38-mk2. This one. This program is provided by Geonics. If you need a copy of it, it will ship with your device, or you can ask me for the download codes. The first step is to convert your files from the raw N38 format that's on the device to the M38 format that DAT38-mk2 understands. So we choose the input file of the N38, and it automatically selects the output file name for you. Hit convert, and be patient for a couple of seconds. The length of time that it takes to do this conversion depends on the size of your file. And it is a little bit non-linear. If you record 8 hours of data in a day, it will not take 8 times longer to process this file. It will take significantly longer. Some of our customers like to break their files into multiple smaller files for this reason. You can merge them later if you want. I usually like to record it in one file and just be patient, get a drink of water or something like that. In particular, this process here where it says sorting data file is a process that scales non-linearly with the length of the data file. On occasion, this process will fail. It'll burp out a file that is incomplete or something like that. And usually that means that the file you got off the device is corrupted in some way. Sometimes you can fix the file manually if that happens. Best thing to do is probably reach out to me with a copy of your data, and I'll see what I can do. And now we're in the last step here. Still watching progress bars. Done. Okay, we can hit exit now and open our M38 file that we just created. So this is the file we just created. I did this conversion a second ago. And you can see that it's the same result both times. I'm going to use the new one. This opens your profile. As you can see, because we're surveying in an urban area, this profile is a hot mess, but all of the data is here and it looks reasonable and real. Well, looks chaotic, but reasonable and real. Next step is to click on the 2D layout button and create GPS-based XYZ file. Here you can select your name of your file output. This is the one I created earlier. So I'm going to call this _1, just to be consistent. All of the settings here are usually pretty good at the defaults. We recommend the settings as below, and just hit proceed.
And this bunch is much faster than the other conversion process. When you're done, you can hit exit. We're actually done with this program now, and we can close the files. I'm going to show you what these files look like in a text editor. This was the raw data in the M38 file. And you can see that there's a bunch of things in here like the raw GPS strings. But there's also a bunch of binary stuff that is not human readable, which is why we had to convert it to the M38 file. The M38 file is now human readable, but it still contains things like the raw GPS formats. You can actually start to see data here. So this is point number 1 of the data set. This is an estimated terrain conductivity on the 1 meter coil and the half meter coil, and then the in-phase values on the same. So you're starting to see real data in here. After exporting to XYZ, you essentially get a CSV. I'm going to actually use our file that just exported. We're going to use QGIS to plot up this data. In order to do so, we need to adjust the header at the top of the file to something that's a little bit more friendly to QGIS. And I'm going to show you how to do that very quickly. The first thing is we're going to delete some stuff that is extraneous from the header, the double slashes and things like that. Pay attention to this zone number though. This is important later when you're importing it into QGIS. Also going to delete this line. And we want to get rid of all of these commas here. I'm going to use a little bit of a cheat code here. I'm going to use edit and replace in my text editor. I'm going to replace all of the commas with nothing and just hit replace all. If you're using a different text editor, you probably have a slightly different menus or different options here, but this is exactly what you need to do. You can see that the commas went away here. I'm going to save this file, and it is now edited and ready to import into QGIS. I'm going to launch QGIS. I have a slightly older version on my computer. If you download the new version, it may have buttons that are in slightly different spots. We are currently in a new empty project. One of the things you can do in QGIS is import Google Earth imagery. There are instructions online on how to do this, or reach out to me how to do this. But basically what it does is it adds Google Earth as an optional layer. I'm just going to double click on Google satellite image, and you can see right now it brings in the whole map of the whole world from Google satellite. Next thing we need to do is import our data. To that, we go to layer, and add delimited text layer. It's because our format of our file is a space delimited text file. This is the file we just edited the header of in the text editor. We're going to open it. There's a couple of options in here. It's space delimited. We don't want to skip any lines of the header. You can see some sample data down here. The X direction is the easting. The Y direction is the northing. The Z is usually elevation. And then you want to be able to set your UTM zone correctly. So this is why it was important to pay attention to that earlier. If we're in the northern hemisphere, it's always going to have an N after the number. So ours was zone 14, and we're in the northern hemisphere, so we want this one. And you can see some sample data here, what it's going to look like in a table once imported. I'm just going to hit add. And hit close. You can see it imported the data here on the left. The annoying thing is we can't really do much with this data in this format. So we actually need to convert this into something called a G package before we can do useful things with it. To do that, we're going to go to right-click on the layer that just got added. And there's an export menu, and you can use Save Features As. We're going to save it as a geo package. We're going to go to the folder that we have our data in, and I'm just going to name it something that is corresponding with the existing file. Just going to leave everything as the default and press OK. You'll notice there is now 2 layers with the same name. One of them is our G package, and you can find that out by hovering over top of the name of the layer, and it will contain the letters GPKG inside the description. Whereas the other one, if you hover over the layer, will contain the XYZ file in the description. We actually want to remove the XYZ file layer now that we have a G package. And if you look closely on the map, you can see a dot here in Winnipeg where our data is. We are zoomed way, way too far from it. There is a button at the top that says zoom to layer. If you have that layer selected, you can just click the button and it will automatically zoom in. And you can see the Google Earth imagery in the background. Next thing you're going to notice is these dots are pretty large, and we can make them a little bit smaller so that we can see our lines a little bit better. There's a button here that if you have your layer selected, it toggles a layer style manager on the right side of the screen. If you click that, you can change the size of your points in your layer. I like 0.2 to make nice small points. And now if you zoom in, the points aren't obnoxious, but you can still kind of tell where they are. The next thing is we started recording with the device on the ground here. So there's a bunch of random GPS points here that are probably not very interesting. I'm going to show you how to remove some data points that you don't like. This is useful if, for example, you had a bad GPS point where you have a spike way out in the middle of nowhere and you don't want that spike to be in your data set. Or if you need to trim your data set for some other reason. To do that, we're going to hit the toggle editing button up at the top. And that is this little button here. And then we're going to go select features by area. And I'm going to draw a box around the stuff I want to remove. And then I'm going to hit the delete button. And then I'm going to untoggle the editing. I'll ask you if you want to save it. Choose save. Obviously, if you deleted something that you didn't want to delete, you will have to go through the re-import process. And you'll delete this layer and you'll re-import the XYZ and you'll go through this again. My notes contain a lot of screenshots, so they aren't very information dense. I have to keep flipping through the pages. The next thing we're going to do is we want to turn this data into a grid because we want to plot it up as a heat map of some sort. Right now, it's just points on the map. We can see where we walked. We have good coverage. But to do that, we're going to go to the raster menu, choose analysis, and choose inverse distance to a power gridding. There's a bunch of different gridding methods here. And if you have newer QGIS versions, maybe they have some more interesting things there. Maybe you get some plugins with different gridding. This one is good enough for demonstration, so that's the one I'm going to use. First thing is to make sure that your point layer is set here. For the search radius, you want to set a value that is approximately equal to your line spacing. So if your lines are 3 meters apart, use a search radius of 3. If your lines are 5 meters apart, use a search radius of 5, etc. You'll see gaps in the data if you set this too small. I'm going to use 3 because that's what I tested last time, and it worked out pretty nicely. The next thing is you want to select which field you wish to grid. So when you're creating the heat map, we're going to select which field. I'm actually going to take a quick tangent here. The EM38 has 2 coils on it at 1 meter distance and half meter distance. This is the terrain conductivity value at the 1 meter distance and the in-phase value at 1 meter distance. And again, at half meter and 1 meter. We're going to start by gridding the conductivity value from the 1 meter coil. It sees a little bit deeper than the half meter coil. you're going to have slightly different results based on which coil you're using. The in-phase value is more useful if you're looking for metal debris. There's a lot of metal debris on this site, and some of it's, construction features like rebar or buildings and stuff, fences. We're not going to plot the in-phase here. We're just going to plot the conductivity. And then I'm going to hit run. And sometimes this takes a second, depending on how big your data set is. And then I'm going to hit close. I'm going to name this layer something useful. So I'm going to hit rename layer, and I'm going to call it CV 1.0 meters, because that's the channel that we gridded. Just so that I remember. If you're going to grid multiple channels, you probably want to name each one of these channels appropriately. So for example, if you went back here and did the same thing, search radius of 3, and then we selected CV 0.5 and ran it again, it creates another layer, and we would want to make sure that we could distinguish between the two of them. I'm going to turn CV 0.5 off, and we're just going to work on CV 1.0 for the rest of this demo. This color scheme that it shows here isn't very useful. It's on a single band grayscale. We could try to stretch and clip various other types of but you can start to see some features here. I'm actually going to go to single band pseudo color. And I'm going to click on the color ramp here. And then I'm just going to click OK. And it automatically created a color scheme here. I'm actually going to say equal interval here and set the interval to 9. This is just based on gut feeling, and I'm going to start choosing some values here. And what I was trying to do is I was trying to choose a low value and a high value that created a nice color gradient here. These are the values in millisiemens per meter. I know based on my site that my soil is likely to be about in the 100 range, so I wanted 100 kind of in the middle of the soil values. And we can look at things this way. I'm also going to set my blending mode to overlay. And so you can see the lines and stuff underneath. One of the things is if you want to see the lines underneath, you can change the ordering of your layers. So you can bring this up to the top, and you'll see your lines printed on top. If you don't like the color scheme here because like it's dark purple or something, we can change that to red or something that makes it maybe a little more. Make them a little bigger. Still too big. Anyway, a lot of this is tweaking to personal preferences. I'll set this to overlay there. You can see right away there's some interesting features in this data. I'm just going to point some of them out on the map here with my cursor. The first is, this was our Lithogen building here with the front dock. There was a manhole cover in the front here, which we don't know where it goes to. We suspect it might, based on this data, it might go this way. There might be some buried pipes or other sewage features or something like that here, based on the position of the manhole cover and this entity here. But this is a single line anomaly based on where the dots are going here. So it might have been better to survey in this direction over this feature. Then you could confirm if it's a multi-line anomaly, if it's something real. The next kind of interesting thing here is you obviously see this checkerboard pattern here that belongs to this back alley. This is probably rebar in here that's not being adequately represented by the EM38. A GPR survey that's really tightly gridded might actually do a better job of identifying the rebar, but there's probably a rebar mesh in there, and that's probably what we're seeing. Next, you see an area of high conductivity here at our neighbor's parking lot. This is a different cement pad and has different properties. The EM38 survey on this section is not useful really at all because it's just responding to such a strong signal, whatever is in that concrete. In the back lots here, you can see obviously the fence line is quite a strong response. Fence lines everywhere around the lots. But inside the center of the lot, you can see that it is actually a very uniform material. Except in this lot, there's a really dark shadow coming through here. And I'm fairly confident that this is an area of low electrical conductivity due to the fact that there used to be a railroad that ran through here. And likely they used a gravel railroad bed. And when they removed the rail line, that gravel bed got smoothed into the soil. So it's very likely that this is an artifact of the historical rail bed that you get this really dark kind of feature coming through here. This is kind of interesting because the railroad will have actually gone through the front here as well. And you can see there would have been loading docks on both of these buildings for the railroad. And through the front here, this is an asphalt lot with actually fairly uniform properties in the asphalt lot. I'm actually going to turn the overlay off because we're seeing cars there. So yeah, you can see this dark color here. So it's more electrically resistive where the railroad used to be. In this asphalt lot here, it's kind of hard to interpret things because you have all of the features from the back alley here, from the building response here. But you actually see a little bit of this dark color, maybe if you're being imaginative, coming through here where the railroad used to be. Nevertheless, you can see the lack of metal in this lot versus here and here, which have different responses. It's nice to know that we don't have a lot of debris in the middle of our yard here. And likewise, I'm sure the neighbors are going to be delighted to know that there's not a lot of debris in here that are lighting up the EM38. This is good for us because we use the center of this lot here as our test point to see if the instruments are still in calibration. Basically, we take our fleet of instruments out there and we cross-check them against each other. And if they all deliver the identical results, that means the calibration is probably accurate. But you wouldn't want to do that in an area like here with all the rebar and stuff because the exact position of the instrument would matter more. Whereas here, the exact position of the instrument doesn't matter much because it's fairly uniform. This image is probably good enough to give to a client if you were in that kind of mood. If you are running a company, you might have some more advanced plotting programs like Surfer or Oasis Montage that might produce higher quality maps than QGIS. But QGIS is free, and we provide step-by-step instructions for our customers with screenshots to produce basically the identical data products. That's it for me, Troy at Lithogen. Thank you very much for watching this whole video.